Well, for years and years, I have been trying to come up with the best design for really powerful magnets. So years ago, I started with another magnet to see how strong we could get. You can see that video on YouTube where I talk about that magnet, and it is a circular Hall-back system of pyramids, and I was able to get about 1.6 Tesla with it, a little over 1.6 Tesla. Well, I've been wondering ever since, can I come up with a configuration that gets us a better magnet, still trying to make sure we get the highest magnetic field strength possible without needing cryogenic cooling or an electromagnet to assist it. This is our latest version. This is one that we call the Giant C magnet, and we can adjust a few things on this one fairly quickly and take it from a 2.2 Tesla, 2.1, 2.2 Tesla, all the way up to 2.7, 2.8 Tesla magnet. This magnet is extremely powerful, but it depends on how much area you need or how much volumetric space you need. If you want a 9mm square area and it's about 8mm, 7mm apart, this one is what you have. So let's take a look at the Gauss meter as we read this now. All right, this is the probe tip, and I'm moving it in towards the center of the magnetic field. And in the center, this is reading 21,000 Gauss, and as I move it around, it stays in that 20,000 Gauss range, 20,000, 21, 28, depends on where I have the probe in this field, okay, and how much I've got it top to bottom, and I can move it around. We're definitely over 2 Tesla throughout this whole region, okay? So now what we're going to do is add a couple of more things to it. Now what this does is this chokes down our space, and we're going to go down to about a 7mm square surface area, and let's see what that gets for us. All right, we've made a couple of adjustments to it. One is I have reduced the area that we have this field in. We now have a 7mm square surface area, but our gap is only about 3mm thick now. And so we're going to see what we get when we reduce that space requirement. And as we focus it in with this, we can see that we're already at 24,000 Gauss, 24.8, which is 2.4 Tesla. There's a 24.9. I'm just moving it across in the surface, in this space, and you can see that we're at close to that 25,000 Gauss. Let's see if we can find a 25,000 Gauss hotspot. There it is, 25,000 Gauss. So this is a 2.5 Tesla magnet with this variation. Then we're going to make one more adjustment and see if we can take it even higher. Okay, we have also modified it a little bit more so that now we only get a 5mm square surface area, and it's only 2mm thick. So that's a very, very small area. But as we've made these modifications, we're going to take a look at the field in this area, and we're jumped up to 26.6, 26.9, 27.1, 27, staying at 27,000 Gauss, so 2.7 Tesla. Now, I've played with a lot of variations on this, and I even have some variations where this gets up to 30,000 Gauss with different combinations. And so, wanted you to see this. If you have a need for this, we have done some other things for other clients as they have come to us. They really don't know what design, they don't ask for the design, so we come up with the design, and they will say what their objective is. We need a high strength magnetic field to do something. And so I'll tell you about one that we have done that worked out really well, and I think it's a really good design for this one. We just don't have a physical piece to show you, but we'll show you what the design was like. So let me just show you a little bit about what the request was. The request was to make a very long magnetic field that was over 2 Tesla. And we'll take a look and see what this was like. What we did was designed our configuration and put it in this kind of an enclosure. We closed down the air gap to where it was only 4mm apart, and we had a wide enough space that was about 3 or 4mm wide, and so it made like this big slot. Just think of it like a CD-ROM drive slot, and you could just slide the item through, and the entire surface of the magnet all the way across was over 2.1 Tesla. So what we're looking for is some challenges that our customers have. We look for these opportunities to help come up with ways of doing things with magnets. First of all, our goal is to make it so that it does not require cryogenic cooling. We also want to do it without needing the electromagnets. So look forward to showing you our next one. Well, we've got a few more designs are in the works right now. Can't wait to see what they do.